My name is Alexis Menard. I work for Intel. I'm part of the web platform team at Intel. Yes, we do some other things than CPUs and stuff like that. I've been working on web browsers for the past, I think, 8-9 years. I've started my journey on WebKit with the Nokia N9, the web browser on the Nokia N9. So yeah, if you have more questions about me, just talk to me after talk. The agenda for today, so I'd like to first start with introducing a bit of the what kind of sensors you can find on your computer or on your mobile device or any other type of devices. Then think about use cases of how you could use them. And then we are going to dive a bit on the current API, so what you can do with the web today, or now, basically. Then we'll talk about the generic sensor, the new specification that we are pushing, and then have some final words on the specification. Well, I don't need to convince you, but you know that, right? Web is everywhere, various platforms, various operating systems, various screen size, device capabilities are different from a tablet to a phone to a computer or TV. Web is everywhere. Input types are different, goes from touch to keyboard-based. And I didn't put in a picture, but you also have IoT devices, like some of them now have, JavaScript runtime, such as, Node.js or Zephyr.js, which I was showing on the Intel booth the past 2 days. As a developer, you really want to target, and tailor the experience for each device, and you really want to leverage all the capabilities of each of those devices. So you really want to tailor the user interface for mouse and keyboard, and then touch when it's touch, right? And that should be the same. You should be able to leverage the hardware sensors of those devices and tailor the user experience for it. And right now, the web is a bit limited in that aspect. Say you would like to build a game like this one. What you require is typically access the accelerometer and the gyroscope that are inside your device so you can create this experience, right? So the user moves the tablets and then the car moves in the game, right? So usually you use two sensors, the accelerometer. You can find them in pretty much all the phones on the market. Some laptops, they actually have accelerometer, like those detachable or two-in-one laptop. They have accelerometer and gyro inside them. Tablets, they have it. So the accelerometer basically measure the acceleration changes of your device, so in 3 directions. And it's very useful as a developer to register, a tilt, like you shake the device, for example, or steps, you're walking. That's how they record your steps during the day, for example, in the health apps of the iPhone. So the accelerometer is what we call an inertial frame sensor. So when you drop the device and it's in free fall, then the acceleration is 0. And when you let the device on the table, then basically the force of the table is pushing upwards the device. So it's basically equals to the Earth gravity, which is 9.8 square meter per second. No, meter per second square. Yeah. And then the other sensor that you typically use for this kind of games is gyro. So the gyroscope is a sensor that is measuring the angular velocity. So it basically measures its own rotation. It oscillates at a very high frequency, and it's usually one sensor that is very power hungry. That's why when you play those games, it's usually drain your battery faster than if you were doing some other things on your phone. Those two sensors, they have a noise problem. The gyroscope is affected by other components. As I was saying, it oscillates at a very high speed. So anything that creates vibrations around it, then kind of introduce noise. So think about the speakers in your phone, or when your phone vibrates, that creates interference. So when you actually listen at those values, you get those interferences. In the accelerometer, what you want to do usually is you want to get the big changes of when the acceleration changed. So you really want to get the big changes. You don't want to get the very little steps while it was moving a little bit in your pocket. You really want to know when you did a step, right? And because the accelerometer includes and is affected by the gravity, it's always very complicated for you to figure out what was the actual gravity, meaning is it your pocket pushing back the phone, or is it actually a big move? And so typically what you do is you use what we call high or low pass filters, meaning you try to filter the low frequencies or the high frequencies, meaning the values that are out of bounds. So you're like, okay, the variation should be about that range. Anything above is kind of noise, and everything below is also noise. But really, as a web developer and as a developer, you don't want to care about that. You really don't want to care about the speaker interference on the gyro, or you don't want to care about this. You really want to know, okay, what's the value, and then was it a big change, or stuff like that. Also, the big drawback of high and low pass filters is that because you're post-processing the value of the sensor, you're kind of introducing latency. So that's a problem for games, if you kind of move fast the tablet and then it takes a while for you to process the data every time, then it will feel that it's not natural. The car will move after you moved, so it's not good. And so how is it solved today? So typically, we use what we call fusion sensors. We know that I was explaining accelerometer and gyro. We know that they have their own problems. So the gravity for the accelerometer, and then the gyro is all the noise around. But maybe if you combine both and then use both of them, you can kind of get the best of the world and then try to get only the relative rotation, for example. So if you were to do the game, you're really interested in the relative orientation, meaning did it turn 180 degrees or 90 degrees, or what's the angle based on the reference point that is the device itself, right? So if you use the gyro and the accelerometer, you can actually get the relative orientation. And you can kind of use the both of them to avoid noise and then have actual relative orientation. Switching gears, completely different sensor. Say you would like to implement a night mode. Your website, it's very late at night, your website has a white background, black text, and then someone is browsing your website and then bam, he gets that in the face. Or you'd like to make a web-based web app that controls your lighting system, and you would like to say, well, it's very dark, so please switch on the light automatically. So you will not do like this guy, which is pressing the button manually. And you typically use the ambient light sensor for that. And you are pretty much, all phones have an ambient light sensor. And many laptops also have an ambient light sensor. And usually the ambient light sensor is used to auto-adjust the brightness of your screen. So if you have a lot of luminosity around you, then they will kind of try to decrease the brightness or increase the brightness depending on your settings. So that's another sensor with some different use cases. What about reacting to magnetic field changes? It seems like, that's crazy. But actually, phones have a magnetic sensor. They can sense magnetic changes. So think about your map app. It's able to tell you where is north, right? The compass app on the iPhone tells you where is the north. And if you ever played with the cardboard of Google, then there was a little magnet on the side, and it was used as a push button. So actually, the magnet was getting closer to the phone, and then the phone was able to see, hey, there's something coming at me. So they were using that as a button. And typically, you get that from what we call a magnetometer. And it's actually a magnetic field sensor. It means that it actually is able to sense magnetic field changes. And if there is nothing close by, it actually senses by default the Earth magnetic field. So you can use it as a way to get the direction of north. Of course, not true north, but at least north. And this is on the iPhone, this is on pretty much Google phones, Android phones. You can find, they usually all have a magnetometer. So how you try, if we wanted to do those use cases that we're showing, how you do today, how you use the web platform that we have today shipping right now to do what I was talking about. you have a spec that exists, which is called the device orientation and the device motion, and actually the spec is called device orientation, but it actually have two DOM events, which is called the device motion event and the device orientation event. So that gives you motion data based on the accelerometer and the gyro. So you could say, cool, I could do the game then. What about ambient light and magnetometer? Well, you don't have them, so you can't do anything. So you can do the use cases I was talking about. Actually, Firefox had something about ambient light and sensing the ambient light, but it's never been something cross-browser anyway. So it stayed as it is. So back to the motion sensor, these two guys, device motion and device orientation even. What's the problem with them? Well, first, they are DOM events. They are not necessarily the easiest object to work with. And it's a bit of an issue for JavaScript runtimes such as Node.js, which are used on IoT devices, and then IoT devices usually have a lot of sensors, and Node.js doesn't have DOM. So those devices, like if you are targeting Node.js, then you're out of luck, basically. Other thing is that their data, the way the sensor data is exposed in the event, is not necessarily convenient with modern APIs such as WebGL. Everything is in other angle, for example, so it's not necessarily mapping very well to WebGL where you have 3D cameras and everything. So you'll have to do a bit of manual conversion to be able to apply this into a WebGL kind of environment. Another problem with them is that the frequency that we pull the data from the sensor is hard-coded. So it's always 60 hertz. And if you consider the use case that I was saying with the ambient light sensor, and then the use case on the right, which is a game, really you don't want to pull the sensor value at the same frequency, because really it doesn't matter if the ambient light sensor, if you update, for example, I did a little demo here where I triggered the Google Map night mode using the ambient light sensor of my MacBook. And it doesn't really matter if the night mode triggers maybe 10 milliseconds or 20 milliseconds or even 1 second after, because after I switch off the light, for example, it doesn't really matter, does it? It's not as critical as moving the game as quickly as possible, because the car is moving really, really fast. So we think that you should have a way to specify at what frequency you want to pull the sensor data. And the reason for that is because if you don't need to pull at a high frequency, then you can save the battery life. The faster you pull, the more you'll use the battery life. Because it's a single DOM event, you cannot pull the same sensor at different frequencies if you wanted to. So, for example, if you had, I don't have a good example, but if you wanted to pull the controls of the car at very high frequency, and then another one detecting that if you stop playing the game, meaning you drop the table, or you drop the tablet on the phone, so you could pause the game automatically. And you really don't want to, inside your event loop that processes the 60 hertz controls, you don't really want to start thinking, okay, is it the tablet being paused on the table, and so on. You really want to do that in a separate event handler where you could say, okay, well, at every 6 hertz or something like that, then I'll say, okay, is the tablet was paused, was dropped on the table, and then I should pause the game. Stuff like that. Also, they work on HTTP, so and no permission is required, meaning that today, if you go to a website, they can use your accelerometer and gyroscope data without you knowing about it. And it works on HTTP. So iframe adds everything, great. There's no timestamp information on the event, so meaning you don't really know when it happens on the hardware. So what about synchronization? You want to know if the gyro value and the accelerometer value, you want to compare them, or you want to do something with them post-processing, and you want to know, did they happen at the same time? You can't do that. You don't know when it happened. That's why we thought it was time to create a new specification for handling hardware sensors on the web. So we've created the Generic Sensor API. It's a working group in W3C. It's part of the device working group, supergroup. And it's a specification that we'll be pushing at Intel, but there are also a lot of members from the community, and Google has been joining us also at improving the specification. So how does it work? So we have a base class, which we call sensor. This one is basically the class defining the basic interface, like how you create a sensor, how you start and stop sensors, how you handle errors, how you handle, when the sensor has been activated, how you get the state changes and stuff like that. And then under them, kind of inheriting the sensor base class, then we have the specific sensors, so ambient light sensor, magnetometer, gyro, accelerometer, or each of them exposing their own type of data. But the mechanics of starting them, stopping them is common to all of them. And of course, in the future, we can add many of them. It doesn't matter. We also have, we took the opportunity to, instead of creating various events, to provide you convenience on if you want to get the absolute orientation or the relative orientation, or if you want just the gyro data, or if you just want the accelerometer data, or if you just want the ambient light data, instead of kind of having various DOM events flying around, then we decided that we could create some classes and interfaces to help you with this. So, and we've created, so for example, the absolute orientation sensor, it actually inherits from an orientation sensor, which inherits from the sensor. And this one actually is very, focused, giving you the absolute orientation sensor, the absolute orientation of the device. And then, for example, we thought, if you do a game or if you wanted to do a health type of application where you like to get the data steps, for example, then you are interested only in the linear acceleration, meaning the acceleration without the gravity. And then we provide you a convenience class for that, so you don't have to remove the gravity, you don't have to do post-processing and stuff like that. So yeah, because it's very flexible, we can provide you convenience on whatever use case you'd like to achieve. It's a very modern API, so it's no DOM event. It's just a new JavaScript. You create an object, you allocate it. You can call start, stop. It's very modern. You can track errors and value changes with modern JavaScript. Like you get an error, you can just promises based. You can catch the errors and then do something about it, which was not the case on the previous DOM event. You get also an on-activate callback. The reason we have a separate callback for when the sensor is activated, it's because on some platforms, it takes few milliseconds or few seconds, sometimes no seconds now, but few milliseconds for the sensor to actually be activated on the hardware and then start, outputting data. We also have obviously the on-change callback, which is called whenever the value of the accelerometer changes. So there is a new value that's being delivered by the sensor. So you get a callback, and then you can access the data of the sensor. So I put sensor data, but in fact, it's it would be, for example, if it was the accelerometer, it would be, for example, the sensor.ax, ay, az, and stuff like that. So each sensor has the ability to expose whatever data it wants with whatever mechanism it wants, whether it's a simple, variables A, B, C, or if it's more complicated data structures such as arrays or whatever. So we don't enforce it on the base class of sensor. We don't enforce how data is represented. We let the DOM class, each sensors, the ability to define how the data of the sensor should be exposed to the developer. You can now request frequencies. When you create the sensor, you can just pass a frequency, and then we'll put it at that frequency. So it's it's a requested frequency. It's not necessarily mean that if you ask for 60 hertz, you'll get a pull. We'll basically call your callback at 60 hertz. No, it doesn't mean that because some platforms they don't allow you to, or the sensor cannot pull at 60 hertz. So we'll try to match the requested frequency as much as we can. Also, the reason for that is that there is also limitation, which I will cover a bit after, around the security, where we want to limit the polling frequency for security reasons. But we'll try to match as much as we can. I was talking about, these classes right there. Oh, sorry. Those ones where, because we have a lot of freedom of inheriting and subclassing and stuff like that, we can provide like those kind of, it's not high level, but this fusion sensor on the bottom, we have the ability to create convenience for you. So for example, if you create the absolute orientation sensor, we provide you two kind of convenience methods. So one of it is the quaternion value, which is basically a 4-element array whose element contains the components of the unit quaternion representing the device orientation. So it's very cool for if you work with 3D and WebGL, it's very convenient. And we have also, for example, thought about a populate matrix where you just pass the array or the matrix you'd like to be filled, and then it will just fill it with a rotation matrix that is converted automatically for you from the last reading of the sensor. So convenience, and again, we can add more. If you think that we need more convenience, then we can add more. So that's the cool part. It's very extensible. So that's it for the API. It's very simple, really. Now, the reason that it was not done before, and it's because the accessing the hardware sensor has always been a bit tricky on the web platform because security and privacy. We wanted to make sure that privacy and security is covered with the new spec. So the new spec only works with secure contacts, meaning it will only work with HTTPS. So on HTTP, the sensor, you won't be able to pull them. It only works on top-level browsing contexts, meaning that any iframe inside the page and everything, they just can't access it unless they have it part of their code. So yeah, so if you have an ad that is served over HTTP, it will not be able to access the context from the main page and then get the data from it. Only on the focused top-level content, think about a website, then there's this payment screen that pops by. We only deliver the events if it's focused. We reduce the sampling frequency when we think it's overkill to have a 60 Hertz frequency on the ambient light sensor. For example, if you pull the ambient light sensor at 60 Hertz, there is something you do that is not, it's, unless your use case is valid and then we'd like to hear about it, there is something wrong with pulling the ambient light sensor at 60 Hertz. Right now, it's limited at 60 Hertz. We would like to open the door at higher frequency, but we think that will probably require a permission dialog for the user. The reason for that is because we've seen a lot of papers of people being able to reverse engineer pin code on a phone that is on the table just by pulling very, very, very quickly the gyro and the accelerometer and being able to distinguish if you pressed a 1 or a 3, even on the table. Actually, I tried it myself, and indeed, you can see very tiny difference between on the accelerometer and the gyro when you press 1 and when you press 3. So people have been able to reverse engineer code. So we think that at 60 Hertz, you're pretty safe, but at 120 Hertz, for example, that could be a problem. Though we have another mitigation strategy, which I'm going to talk about right now. Values are dispatched only on active tabs, meaning that if your page gets, if you're not looking at the page, then we are not delivering the value of the sensor. We are not delivering value changes. We hear you. There are people that think about backgrounded use cases, where the apps such as, for example, Facebook or whatever, then stay in the background and do something with the sensors. We'd like to hear about the use case, and then maybe we can see if we can find a way to expose and dispatch values when the tab is not active. But right now, it's going to be only on active tabs. Again, I was saying because we want to allow you to pull at higher frequencies, then we integrate with the permission API, so you can actually we can actually show up the permission dialog in Chrome asking the user, would you like to grant access to your sensors or stuff like that. And then one of the mitigation that we do is that we apply some rounding on the data of the sensor. Reason for that is to mitigate a bit the fingerprinting, because some sensors output the value differently from some other brands. So then you'll be able to distinguish the user based on the value that you get. So if the value, for example, have a 6-digit precision, you may be able to identify the vendor of the accelerometer, and then you may be able to identify the user based on that. So we run them at what we think is a good precision for you to implement your use cases, and then that kind of mitigates the fingerprinting. Then we are looking also at other use cases. Again, WebVR is a good example. We think that, so in order to do WebVR and to provide a great experience without motion sickness, where you have to render every frame at 90 FPS, you usually need to pull the sensor at a higher frequency than 60 Hertz in order to make sure that you have the data as fresh as possible so that you can update the images inside the head-mounted display. So then you can fight motion sickness. But of course, because it's higher precision and higher frequency, then we have security, there is security concerns. So we have probably to provide additional permissions, and user needs to grant access. Something like, oh, you're about to experience VR, would you like to grant access to higher precision, or would you like to grant access to your sensor with higher precision, for example? We have to come up with a solution for WebVR. Something we've been looking at as well is the gamepad API. So right now, you have a gamepad API on the web, but it was designed maybe, I think it was 6-7 years ago. And it was made basically with Xbox or PlayStation controllers connected to your computer, basically. Then comes VR with two-handed controls, where each of them has an accelerometer and a gyro inside them, and then the gamepad API just doesn't work. So in order to cover that use case right now, when you want to do WebVR, then they have extended the API with the concept of hands and being able to pull the accelerometer and stuff like that. But we think that if you use the generic sensor API as a base, it's exactly what you need, because you really want to know the status for each of the hands and the status of the accelerometer and the gyroscope, and then also if a button has been pressed or not. That's all you need. So we think the gamepad API could be based on the generic sensor, and we're still discussing with the WebVR community as well as the old gamepad API folks on whether we could make a new generation gamepad API that covers the VR use cases and is based on the generic sensors. So now you're curious about the shipping status, of course, of this. Before I get to it, then we need you. We really need you. We would like you to give feedback on the API, how well it's integrated in the workflow of JavaScript, in the workflow of modern JavaScript, the integration with the existing APIs. We would like, if you have use cases that we haven't thought, then feel free to share them with us, because we'll be happy to look at higher frequency polling. We'll be happy to look at how we could expose data better, stuff like that. If you think we are missing fusion or what we call deviated sensors, like those convenience I was talking about, feel free to tell us. Then we'll be happy to add them to the spec. It's the moment you have for giving feedback. And after it's shipped, it's a different story. Also, if you don't like the way the sensor data is exposed for each of the sensors, it's the moment to tell us that is not convenient. I gave the example of the populate matrix and the quaternion. If you have better ideas on how we could expose the rotation of the device or the ambient light sensor value, which is very simple, but if you have ideas or better ideas on how the sensor data should be exposed, feel free to share it with us. And of course, make noise about it. If you like it or don't like it, make noise about it. Talk about it on Twitter or Medium, whatever, and then or conferences, and tell us how great or bad it is, so we can fix it. So back to the origin trial, back to the shipping status. So it's going to go in origin trial in Chrome 61. So if you're not familiar what it is, origin trial, it's basically a process in Google Chrome in which before an API ships, it goes what they call in origin trial. So any website or any origin that is interested in trying it can request a token, and the API will be enabled whenever a Chrome user accesses your website by default. So, for example, say Facebook would like to try it, then they will request the activation, and then whenever you browse facebook.com, then these APIs will be enabled by default. No flag, nothing requested. And then when the trial expires, your token expires, then the API doesn't work anymore. But then usually when the trial expires, then it is either, so there are two exit paths. Either it was a successful trial, everyone says great, then it becomes shipped by default for everyone. And then otherwise it's like, yeah, well, we have to work on the API, so we're going to do another trial when we'll fix the API. So in 61, which is 2 releases from now, I think the stable is 59 now. So a month, 2 months from now, you will be able to request a token on your website, or you can just go to the flags in Chrome and enable it by default if you want to play with it today even. You'll be able to play with the accelerometer. You'll be able to play with the linear acceleration sensor, with the gyro. You'll be able to get the absolute orientation sensor and the relative orientation sensor. So that's getting you a long way already. And we think that if we nail the motion sensor, then the rest is easy. The ambient light sensor is coming at a later date, the magnetometer as well. We still have open questions on privacy and security bits. So we are trying to figure those out, and then we do another origin trial with the ambient light sensor and the magnetometer as well, so as a separate trial. But hopefully we can ship those ones first and then add the other ones. What about the other vendors? So we've heard good feedback from Microsoft Edge, and we've heard good feedback as well from Mozilla. However, Apple, they never comment anything, so we don't know. But right now, there is no implementation that have started on the other engine. So that's why we need you to make noise and talk about it, because if you think it's great, then the other vendors will feel like, okay, well, we have to implement it. Everyone is requesting it. So I put a few links. So there is the motion sensor explainer. It's a great document that we've wrote explaining in more detail of what I was covering today, you know, the accelerometer, gravity, noise, drift, you know, fusion sensors and all of that. I suggest you read about it. Then we obviously have the generic sensor spec, which you can browse. It's just like any spec that you're used to. We have the device API working group, so feel free to, you know, post on the mailing list, and then we'll be happy to, you know, answer and then help you, you know, using the generic sensor API. And then if you have use cases, if you have feedback, just feel free to send an email. We also are on Freenode on IRC, so in the Chromium channel, so you can find myself or my team. And then we have Twitter. Feel free to, you know, ping me on Twitter or any other platform. I'll be happy to